Schubert was born in Vienna. That's the end of the quiz. And we can see that Rosie is the winner.
There isn't anyone to show it to, John.
And you see two cuts, heads and tails.
Yeah.
Call it, I guess.
At number 5, it's Imhotep with Hurts Like Crazy. And
let's all go to the lobby. Let's all go to the lobby. Let's all go to the lobby. Get ourselves some snacks.
Hello. Is the mic on now? Thank you. Thank you for reminding me of the order of things before I don't know. I can't remember what my record is for not remembering to turn a mic on. It was probably like 15 minutes. So thank you. Thank you for saving me on that. Yeah, we're doing more Fool's Errand today. I thought I just got in under the deadline and made this buildable, but apparently no, I forgot about all of the stubs that I've added. So give me just a second to commit what I've got. Because I'd like to show off the introduction, which we've more or less got working, and then maybe like have a little talk about
No, Ralph, this means you're failing English.
Me fail English? That's impossible.
Months, Nelson, you're failing history, geography, and math, but you're doing...
Jeez, I feel called out, Mad Moose. You're saying my English is... You're saying I don't speak good. I mean, to be fair, I did almost fail, like, English all the way back in high school, but I don't know. That's... In hindsight, I think it was just because I didn't really absorb any of the subject material once I kind of figured out... I mean, once I started actually kind of reading books and films for fun as opposed for school, then I was like, oh yeah, that's why themes are important. That's why subtext is there. That's why the author has decided to do all these clever things. But at the time, I was like, this is just, you know, can you just tell me what I need to, like, spit out on the paper to get answers that'll make me pass the exam? Amos says, Superman speaks good, you speak well. Okay, that's good to know. Does Superman speak good because, I mean, Superman isn't really from New York. He just lives... Well, he doesn't even live in New York, officially. He lives in, Metropolis City or whatever the hell it is. Or is that the... I'm thinking of... Is it Metro City or Metropolis City? Or just Metropolis? Or am I getting this confused with Sonic the Hedgehog? Doesn't matter. None of this matters. What I really should be doing is pushing this before my laptop in the other room turns off. Yeah. More grist for the porting mill. Push. Okay, good. My laptop in the other room can run a battery in peace now. And if I pull this here, okay, let me just do what I have to do to turn off the other engine. I think this means it'll build just... The new code won't be in the critical path, so... Should be okay. Ah, there we go. Okay, so... to catch everyone up, here is the introduction for Fool's Errand. It is... For context, Fool's Errand is a 1987 game for the original Macintosh, which was later, re-released for DOS and Amiga and Atari ST. Those versions, those ports, kind of subpar compared to the original, and just look at it. Just look at how nice the original is. In fact, I'm gonna zoom right in. Let me get the zoom sorted. Screen. There we go. Oh, Mammo says, no, I was just riffing on Superman does good, you're doing well. If someone says I'm doing good. Oh, I get it now. Cause he does acts of good. I understand now. Thank you for filling me in on what I missed. Okay. Look at this. Look at this incredible introduction. It's just... And all of this is done with the classic Macintosh API, which we're kind of in the process of making a fake copy of. Sorry, forgot about the flashing warning. But yeah, just blitz, drawing lines, filling in patterns, filling in rectangles. And yeah, introduces us to the story. One sunny day, a light-hearted fool strolled along a hilly path, whistling a merry tune. A long wooden pole was slung over his shoulder, and attached to it was a cloth bundle which carried his life possessions. What a marvelous afternoon, he explained, to no one in particular, pausing to appreciate the lovely countryside. Soon the trees parted, and the path led to a small clearing, ending abruptly at the edge of a treacherous cliff. But the fool was undaunted and kept at a swift pace, steadily approaching the sheer drop. "Your folly is most curious," a voice boomed. "Have you no fear of death?" Just as one leg dangled over the side of the cliff, the fool hesitated. "Who dares to interrupt my errand?" he demanded impatiently. "I dare," the bright yellow sun replied. "Well, then," the fool considered, "I seek the 14 treasures of the world, and I am told a man that strays from his path is lost." "That may well be true," spoke the sun, "but I fear that you're already lost. Take this map as my gift. It will aid you in your quest. There we go. That's the end of the introduction. And that's pretty much all you need to know for the game. There is, you play this guy who's just kind of just wandering along, wanting to find the 14 lost treasures of the land, but doesn't really kind of have much of a plan for doing it aside from just going in a straight line. And then, obviously, once you kind of get this map from the sun, then you realize, oh, hang on a second, the map is in a bunch of pieces, and I kind of don't quite understand what comes after what. And then the game kind of goes in a non-linear fashion. Like, you can see all of the chapters for the story, like all the titles for the chapters of the story, but you only have access to like 5 at a time. And then every time you complete a chapter, which generally involves solving a puzzle, you then see slightly more of the story, and then so forth until it builds up to a pretty cool end game puzzle after that. So, yeah. Now, in terms of how the game is structured, the introduction is its own floppy disk with its own exe on it. The game is a different program entirely, which is where we're kind of up to now. Ideally by the end of this stream, I want to see something rendering on the screen, even if it's not very good. We'll see how far we can get into that, because there is quite a lot of code in the game exe. The game was originally written in ZBasic, which is like a compiled version of everyone's favorite beginner programming language, but it also has like a bunch of extras bolted onto it, which allow you to do things such as call the Macintosh Toolbox API, or get pictures from the resource fork and stuff like that. So I wrote this kind of crappy homemade disassembler to take, I don't know, the compiler outputs Motorola 68K assembly. It's just not very good. I mean, it's not optimized, which is good news for us, because the fact that it is not optimized means it is actually quite easy to read. All of the instructions are very kind of blocky and self-contained. Like, everything, despite the fact that there's like a ton of registers, the only ones that are really used are like DO and AO, and occasionally D1 and A1. So yeah, my disassembler just basically just assembles just enough of the 68K instruction set to list what's going on, and it goes through and it translates the special fixed addresses used for the variable store and the heap store, and the string. There's also kind of like a data block, which I think you can use in BASIC if you do like you can define integers and strings, which you can then like read in a stream, and that's what this data block is. So there's actually not very much for it in the main exe. There's some numbers and then some strings, which I get. I mean, actually, yeah, the string table can be accessed. Well, sorry. The actual program, you just define, you spell these out in line, but for the purposes of reverse engineering, these are fetched from this table in that. Mamu says, did you consider going higher level? Seems ideal for a simple decompiler. I did, and then I kind of So, to answer your question, I was wondering, like, initially I was thinking, ooh, this is kind of neat. I might be able to reuse this again for 3 and 3 and Puzzle Gallery, which are 2 other games that Cliff Johnson made. Neither of those games, I'm pretty sure, are using BASIC. Those are just written in C. So at that point, it was like, I could write a decompiler for this, but then that would just be... I mean... it would have I mean, like, the other kind of... So, like, the hard part of the decompiler wouldn't be, like, the program flow. The difficult part would be introspecting what each of the data types are, because you have to kind of figure that out on inference. And at that point, it's like, I could spend a bunch of time doing this, or I could just read it with my human eyes, and it would probably take about as long. So, yeah. Oh, yeah, and like, sometimes, I mean, the other kind of complicated thing is that occasionally, because this makes like raw calls to the Mac toolbox, you can't trust the data type that was originally being used. Like, occasionally, like, they may like declare an array of ints, which is, you know, a 16-bit type, but then they use it as a you know, just a block store for storing some other kind of Macintosh struct, which would then kind of, I don't know, it could either be like, there's all sorts of kind of like little hitches like that, and then all of them kind of added to my I don't know, the friction of writing a proper decompiler. And I was just like, you know what, this is actually quite readable. Maybe I will just use the assembly output and see how far I get with that. And the answer was pretty, like, I managed to do, like, to reverse the code and reverse enough of the add enough Mac toolbox drawing stub things to do the introduction in less than 3 weeks. So I think that's pretty good turnaround for, like, a Greenfields project, but I don't know, maybe at some point, I'm not gonna lie, it is kind of a pain to have to figure out the indexing on some of these arrays that they've got, but it's, I don't know, the reworking the disassembler that I've got to I mean, yeah, it would mean having to like redo the disassembler that I've got to be like token based, and then I'd have to like do some kind of pass to convert the tokens back into instructions, and then blah, blah, blah. Yeah, it's just, it's work, but I think we can do without it, at least for now. Maybe I'll change my mind later. Okay, so that was the introduction. Now, where did I get up to with the main game? I think there were some symbols that I need to add, or some stubs that I need to add. Yeah, okay. Quite a few stubs that I need to add. So let's do that. Let's go back into here. Also, hey Absentia, sorry I did not say hello earlier. That was very rude of me. Let's go. Okay, let's just... Okay, detach this terminal so that I can keep an eye on it. Then we'll just... Okay, and yeah, like we've got all the definitions in here. It's just a question of... Actually, I don't even need to look at that. I've got all of the function IDs in here. I just got to add them here to this list. So... Uh, 129068 6244 61 EC 61. Okay, this one in here. 128 6186. Uh, 6154 5F EA. That's another one. Is it? Oh no, 5FEA. Okay, then we've got B4, then we've got 9E, BAA, 5B30. Oh, and 4472, which we've implemented. Is that all of them? Not quite. Just a couple in here. So 2202. Wait, one C2C. Why? Oh, okay, that's where I got up to. Oh, yep. In 16 arc 1. Let's see, 30. And then, let's see, 4A in 16 arc 1. Oh, okay, I already defined that earlier. Oh, okay. I just can't read. How did I miss one C2C? Oh, I get it. Like, this is... Oh, actually, no, I just legit missed it. Okay, that's kind of a problem. Mamu says, I had some success with a simple expression decompiler. It contained a lot of with if conditions and such. For Blade Runner, I made an x87 expression decompiler, helped a lot by the x87 being stack-based. Right, okay. Yeah, this... Actually, yeah, I've never touched the x87. That's the floating point coprocessor, isn't it? Did that, I'm actually curious, how difficult was that to, like, convert to the C equivalent? It sounds messy. Okay, did I... Ah, alright, okay, still a couple left. So, one here, 2BOA, to be C6. Ah, crap. Two E3. Come on. Gotta be near there. 3536. 3536. And 39A0. Cool. Okay, now we just got to add in a couple of toolbox stubs, which we can easily do. Set cursor. And Then we've got two Z basic mystery functions, which I'm probably gonna have to crack Gitra to figure out what they do. I think we've got all the unks down the end. Yeah, we do. Okay. And 158. Okay. Excellent. Oh, Mamu says, yeah, Blade Runner did a lot of floating point 3D math. I once spent a couple of hours working out an expression, and then the engine multiplied the result by 0. Oh man, yeah, I sympathize. Love cool code doing cool things and then multiplying it by 0. Oh, excellent. Okay, so we're at, yeah. So what's happening here is that there are parts of the code which have an infinite loop which kind of pumps the event bus. The mouse cursor isn't currently moving because in these sections we need to like add in a delay. The original code does have like waits, but often it'll just simulate waits by just checking the tick count all the time. And that doesn't really work with ScumVM because we have a fixed frame rate and we need to yield control back to the engine to say, yeah, update the screen. So I want to know is where in the code base are we? Okay, it looks like we're in C6A. Which should be... Okay, and yeah, there's quite a lot of busy loops in this, or like waiting for stuff to happen loops. Okay, so it's polling for events. Okay, so one of these methods polls for an event. Oh, okay, it's this one here. So it's polling for an event. It's then, I'm guessing, checking for the mouse. What is the? Okay, event code. We need to, yeah, okay, mouse down. So let's just convert these so we can actually see what's going on. K mouse down. K key down. I've not implemented. All I've implemented so far to get the introduction working was support for mouse events, or at least basic support for mouse events, like clicking the mouse. It's interesting because, yeah, like before this, I did like a lot of work. Hey now, little mouse, I hope we understand one another. Hey now, little mouse, show me what to do. Hey.
Jack took a year off from presenting to concentrate on his music and scored a worldwide hit with this song, which was inspired by a vermin infestation.
Forgot about that joke. Inspired by a vermin infestation. Yeah, key down. Okay, mouse down. Okay, so we have event codes for things. You know what? If I'm being strict, we should probably say Oh, okay. It's... Oh, because I guess the equality operation just changes to the right one, but that's okay. Anyway, so to go back to this... I think what we need to do... Yeah, so we've got this code here which checks for the next event. I'm guessing in here that we're going to have to put... Because, like, look at all this stuff. Like, all of these drawing commands. We can't see any of them because nothing's yielded to the screen yet. But clearly it's done something. Mamu says, can't you change it to a class enum to make it more strict? Possibly. I don't know, what would that entail? I don't know very much about class enums. But I mean, like, I'm pretty sure it errors out if you try and set an invalid one of these. Like, it's just comparisons or automatic. Like, look, if I were to go, 46 watt. Oh, actually, yeah. Oh, we wouldn't see it in here, but, okay, so we've got, like, get next event. Yeah, I would have thought that, like, if I were to go, like, this var ev 46 watt equals 4, like, that'll be a compile error, I'm pretty sure. Yeah, because I'm not providing a full event code, and that's honestly the thing that I care the most about. The comparisons, is fine. I just gotta remember to type them properly. Okay. Okay, now the other thing that I need to do here is I need to put in a yield. Because, like, this is in a do block, and it's waiting for 7BE. Oh, it's waiting for the mouse button to be clicked, I guess. Okay. I guess we'll just do... I mean, if we do like a G toolbox delay 0. Just so we can see what's going on. Okay. Alright. Did it actually do anything before going to the infinite loop? I mean, it looks... yeah, okay. I mean, it must have called all this other code, which drew stuff to the, to whatever surface is there. But evident... Oh, okay, so... That's interesting. So this instruction here basically tells the code to set the graphics port, aka like the structure which says which buffer to draw on, to this. I'm interested to know if that's actually been set up properly before we even get here. If not, then we gotta figure out which piece of code is missing. Okay. Quit anyway. So sub 128 DFE. I probably should put in some kind of warning string for each of the methods that are like missing missing important information. Oh, okay. Didn't even get there. Sub 128 C6A. That's what I meant. So okay. So line 102. So okay, not very much has been set up. Oh wait, okay, no. This could be an issue. So sub 129.068. So that's going to be a prerequisite for pretty much everything. And as you can see, there's nothing in here. So we're probably going to have to focus our efforts on porting that just to get off the ground. I don't know what's in like module 129. That seems kind of weird. But whatever. Okay, so to do that, we open up our disassembly, scroll down past all of the stuff which we're eventually going to have to port, and then go straight to... Okay, so like the start of this function is about loading data from the puzzles file. That, to my mind, seems like it'd be kind of key piece of stuff that we need to do. Sub 129.068. Okay, well let's just implement all of this stuff as we go. So void full game sub 129.004. Okay, this var i1676 equals 0. Because yeah, it's quite easy to read this as move 0 into register do, move register do into this, which gives you that. Okay, this one here is okay. That's gonna be like an event handler. I've not figured out what the ZBasic address for the event handlers. Reversing ZBasic is kind of difficult because I have ZBasic version 3.02, which is useful for testing, and I know which address the event handlers are for that. I don't know what the address handler for ZBasic version 3.00 is, and that's the version that Fool's Errand was built with, and I don't know, I couldn't find a copy of that, so we're just going to have to make do the best we can with what we have. Okay, so that, yeah, we'll just keep that in there with a fix me. We'll also add in okay, SF, like set false. I don't know. I don't know what's going on here because we overwrite do like a second later. So I'll just pop that in there. That might be just some kind of like automatic boilerplate, like it will just automatically set do when you do the handler, but you know, a moment later we overwrite do, so no idea what the point there is. So we've got the number 1 which gets pushed to the stack, and then GZ basic stir 1110 G. Okay, so this uses the ZBasic file API. It uses the ZBasic file API and the Macintosh file API. So we're gonna have to implement both of those to some varying degree, which is gonna be fun. Yeah, and we're probably going to have to implement it for real because it's going to be using that for data. And then okay, so it's opening file handle number 1 to like the path fool's puzzles, which makes sense. And then okay, and then after that it's checking .76 equals 0, which is odd because we just, oh my god, I hate whatever autocomplete is autocompleting 0 to 0x8. That's really annoying. Okay, then after that okay, weirdly it's got fool's puzzles defined twice. Same thing. Okay, and then GZ basic close 1. Yeah, it's like it. It's like it's like it's checking that to be correct. E6 equals 0. Oh, I think I understand. Okay. So it's setting up a handler, probably the file event handler, and then unsetting it at the end. And then the idea is that I guess the file event handler is meant to pick it up. So let me just open up the ZBasic manual. Scanned from the original loose leaf. So here we go, event trapping. ZBasic offers a simple set of statements and functions to determine when certain Macintosh interface type events have taken place. Yeah, there's also a file event, I'm pretty sure. Or a data event, I thought. Is it dialogue on dialogue button, Apple menu, def mouse, open help? Okay, maybe maybe it's actually like a... Yeah, it could be that maybe this is pushing like... Is there a function at 3F2? That's what I want to know. So there's like 3A and 3F2, which are the two variables. Okay, no, 3F2 is... there's nothing there. Also, what is the relationship between A5? Because I think below the stack is global memory and above the stack is like special memory. I think that's how Macintosh memory maths works. Okay. When an application starts up, register A5 is set to point to the boundary between the application globals and the application parameters. See the memory map in chapter 1 of volume 2. Okay, we'll do that. Yeah, this is our guy. Okay, so A5 is set to here. And like all of your stack and all of your program memory is down here below A5. So A5 minus something. Or is it plus? No, it's... yeah, it's minus, I think. Yeah, minus. So that would then mean that above that is going to be plus, which then could mean the jump table. Like, is it referring to something in the jump table? The other option is that we can fire up an emulator and figure out exactly like what it's meant to be pointing to. But I need a... so like to give to... okay, so... so the string table uses uses a fixed offset. So like minus 2d6 below A5 is the location of the string table pointer. 7d6 below is the file handle. Heap. Okay, so the heap is actually at 2CE. Interesting, okay, and then we've got 8EE, which possibly is like one of these event handlers. Yeah, okay, so 16-bit offset from here. And then... oh, I see, alright, It was a long time ago since I've written this code, so I need a hint. Okay, so we have this jump table. Do I print the jump table at any point? Okay, good enough. Found the data chunk. Okay, and here's the jump table. Okay, I kind of wish. Okay, so we'll go jump above A5. Oh wait, X. A4X. Below A5 equals. Okay. Above A5, below A5. Table length, table offset. Oh, Mamu says listing the sizes in decimal is wild. You mean like the hacky debug code that I wrote here? Or just... I don't know. It's hacky. I just need an idea. Okay, and now for the maths. So we've got above A5, which isn't used. We've got below A5, which isn't used. Huh, okay. How do we... What am I missing? Okay, so that just sends a number to A5. Oh, the diagram I had from the documentation. What I mean, like, I have nothing bad to say about the ZBasic documentation. Oh, you mean the Macintosh, the inside Macintosh? I mean, like, it's all right. Like, it's quite comprehensive. It's nicer to read than. I mean, like the main takeaway that I've taken away from this is that the Macintosh API is actually quite nice and well designed. Like, it doesn't make you want to tear my eyes out and dash them into the sea. Like whenever I have to read like Windows code. Yeah, it's quite like. I can't overstate how little I had to do to get the introduction to run. Like, it's very nice and lightweight. Windows, on the other hand, Jesus. Oh, okay. Right. So it's low. It's. Now, how is it different? Because like we have. So, let me just vertical split it for a bit. Because we have this command here, which loads like a raw value from here. Oh, I get it. Okay. Sorry. The variable store is stored in register A6. So all of the fetches in a program like Z basic program memory use register A6 as a source. Register A5 is reserved for like internal Z basic state. So which is like the default kind of global variable store for a Mac program. Mamu says the current Mac developer documentation is a travesty. Yeah, the few times I've had to like fish around in there, I've not had a good time. They've it's not as good as their their past efforts in making nice documentation. Then again, I don't know. I never liked Objective-C, so I'm biased. It's like the kind of, I don't know. It's like reading Elixir or Clojure. Like, it just kind of, it makes my brain kind of snap in two a bit because of the syntax kind of inferring something else. Especially, it's especially kind of a mess with like Objective-C because like, you know, you're expecting C and then it's nothing but. It's got like a whole weird kind of calling convention going on. But I don't know, maybe I could learn. Maybe I could learn how to stand it, given the right incentives. Okay, 5e. Yeah, I mean, okay. This function is odd, but we're not quite there yet, so we'll worry about that later. 68 is the one which we need to implement in order for the engine to start doing stuff properly. It looks like it initializes a bunch of stuff. Oh, that's a 1. Oh god, another heap reference. Do I have this one? 5, 8. F. Oh, I do. Okay. It's a pattern buffer. Okay, so it adds 4 to this. 16, 6, 8A. Okay, so this must be setting up the pattern buffer, I suppose. Plus 4. Oh wait, no, because it's 4 times, because it's treating it as an array of int 16, and a pattern I believe is of size It's like 16 bytes. Yeah, so that makes sense. So really it would just be this. So it's 4 plus this. Is it 8 bytes? Is that how big a pattern is? Oh, it's 8 bytes, sorry. 1, 2, 3.
Ice cream with vodka may not make it.
Oh no! Come on, Sakai-san!
Hey Ryu Shinaka, how's it going? Could do with some vodka, actually. No. What am I saying? We're not even in painful territory yet. It's fine. Okay, so it's doing the equivalent of adding 1 to this number, and then setting AA55. Okay, and then it just loops for... Yeah, okay, so there's a loop in here. So we go for int I equals 0. I is less than 3. Oh, sorry, less than or equal to 3. One two nine O D8. Okay, we may have to like we're probably gonna have to unroll this because I changed the type so it's not in 16, but that's alright. We'll just prototype what's meant to be happening. Five, 8, F4. Plus 2. I see, okay, and then yeah, alright, I understand. Okay, so this is for pattern 1. This is for pattern 2. I think that should work. Result of multiplication type int is used as a pointer. Okay. Okay, so that's that lot. That's done. Oh, okay. So we've got is this just peeking from like random? Oh, it's a move L, so it's looking for just variables from the Macintosh memory, I suppose. Yeah. So 904, where the hell will that be? 2308. Unless I've forgotten what peak long does. Yeah, it's literally just giving it a raw pointer, huh? Okay, is... Ah, here we go. Okay, so... Global variables. This appendix gives an alphabetical list of all system global variables described. Okay, so... Current A5. So... We are currently... minus 72. Uh-oh. What? Come back. Stream. Oh, sorry. Okay. What's... Oh, no. Get out. Get out, Firefox. Okay, we're back. Sorry about all the drop frames that inevitably just happened. Yeah. For some reason, Firefox just decided to increase my load to the ceiling. So give me a moment to fire up the stream stuff again. Any second now, Twitch. There we go. Okay. Hopefully, stream tech's still working.
You already have it, John.
Uh-oh. Stream tech not working. Oh, no. It is working. Okay, just one more time to see if it's not a fluke.
Silly move, John. That attracted
Why
the
is there a
enemy's
big delay?
attention.
That's kind of weird, but okay. It's playing it back. Audio seems to be working, so all right, we're good. Stream back on rails. I hope. Okay, so it's AV sync is slightly off. Is it? Oh crap, it is. It's off by a lot. I don't know how to fix that. I can try quickly cutting to a break. Is that any better? It's... I think it's slightly better, but... I don't know. I can kill the stream if it gets too bad, but... That seems... I don't know. Oh, it was fixed after pause play? Okay, that's good to know. Like, I definitely feel a delay looking at my... looking at my monitor here. Like, a small one, but... actually... Yeah, right. I made... Actually, if I hide the camera... Did that change anything? It's not like it's a karaoke stream. Yeah, okay. Point taken. Alright, well, camera is a little slow, but the video feedback seems to be fine, so we'll press on. If it gets bad again, I'll consider killing the stream. Okay, so now we've got to ask ourselves, what the hell is this trying to get out of main memory? So it's looking underneath the current A5 address, which, if we go back to our memory map, that might, I'm guessing there's something at a fixed... Okay, memory map in chapter 1 shows the location of the screen and sound buffers. Trap macro. Okay, so it's the application globals. You want to tell me more about what's in the application globals? Okay, the location point will point to the first quick draw global variable. Oh wait, no. It's quick draw globals, not applicate. Oh no. Sorry, it's... Yeah, sorry, there's a difference between register A5 and the address pointed to by register A5, which we got to be... Yeah, okay, so A5 is currently pointing to current A5. So I guess it would be in application globals, maybe? Address the boundary between application globals and application param... Yeah, okay. I get... Okay, I suppose... Okay, if I were to bet, I reckon that's going to be the current graphics port, perhaps, or something to that effect. Like, do we use 5C anywhere? Can we infer anything from that? No, we do not currently use 5C anywhere. Oh, it's only a word too, it can't be a pointer. So it must be something. Perhaps if we were to look around for like where 5C gets stuffed. Oh, we got 5A and we've got 5C. And 5A is definitely in use. Okay, so... Right, so it must be some kind of... Because here we've got, like, 5A being used as the right-hand bound for a fill rectangle command. So it must be related to the quick draw drawing. Okay, I do have a PDF for like quick draw. Maybe that's a better thing to look. Okay. Global variables. Ah, here we go. Assembly language summary. That's us. We love assembly language. So 3158. Oh, okay. It just lists stuff that's there. It doesn't tell you the layout of. It's not really the thing I was looking for. See the discussion of init graph in the quick draw routine section for details on how to access the quick draw global variables from assembly language. Okay, yes. Init graph. Tell me all about. Okay. Assembly language note. The quick draw global variables are stored in reverse order from high to low memory and require the number of bytes specified by the constant graph size. Most development systems, including Lisa Workshop, pre-allocate space for these globals initially below the thing. Oh, okay. Is it not going to... Sometimes the documentation doesn't... Just straight up doesn't tell you what... It just says, you can use these handy aliases, but it doesn't tell you what the alias is. If that's the case, that would be kind of annoying. Okay, so like one example was like... Rand seed. Do we have any information about what... Oh, okay. Yes. Oh, maybe it's getting screen bits? I don't know. Okay, so we've got like the port, white, black, grey, light grey, dark grey, arrow, screen bits, and Rand seed. Oh, I could check the executor source. That's another try. Executor source. So we have... So this is like another implementation of the Macintosh API. Where's the definition for Qt globals? Oh my god, really? Okay, Oh, is it done with macros? Yeah, okay. That I understand. Oh, this is the exact random number generator from... Or at least this is what Executor has, the random number generator. I'm not sure if this is the one that's used in... Okay. Really? Forward delete declarations in quickdraw.h. Do not delete this line. Oh, okay. And include... Like, all of these things reference quickdraw.h. And is it seriously not in the... Not in this repo? Okay, that's annoying. Screen bits. Oh, okay, because screen bits is in line, so it could actually be like fetching an offset within the screen bits. How did I do this for the introduction? How did I know what the correct offset was in the introduction? Did I write myself a note knowing that I would like run into this exact same freaking problem again? I probably did. I did. Okay, so I did find out where everything was in memory and I wrote it down because I was frustrated. Okay. Thank you, past me. We don't have to reinvent the wheel. It's okay. We can fall back on this. So it's 72, which is going to be interesting. All right. So screen bits is 70. Oh, we're just doing 2 peak word commands. Why though? Why would we do that rather than just... Okay, so minus 72. Oh, I just guessed it was the width and the height, and it turned out to be right. So, okay, we'll just copy paste this in verbatim. Makes sense because then it's used in like a rectangle calculation later on. Wonder how long it took past me to figure this out. Probably a while. Okay, so we've got 5C as window height. And this is separate from like the canvas height. So this is asking, or fetching from like fetching on what the screen resolution is. Weird how they don't have a API call for this, but it takes all kinds. Okay, so then we've got like the halfway point, I think, for... Yeah, 342 is the... Okay. So that's kind of the internal height and width, or calculating the midpoint of those. Okay. 138. So if this is equal to 0, it's a weird thing to check, and this var I1658 equal to 0. Okay, then it sets this variable thing here. Okay, and then inside here we've got this var I1637A equal to 1. And we move... Yeah, okay. Hey Bruno636, how's it going? Weird. Okay. I mean, yeah. Oh, I don't know. Tonight's one goal is just to get something, anything rendering on the screen. Doesn't matter if it's crap, doesn't matter if it's broken. We're just trying to get something. Breno says, do you do game dev as a day job as well? God, no. Absolutely not. I imagine that if I did, it would kind of probably take the shine out of doing it in my own time. But no, I do something very different from my day job. What are we doing? Okay, so first we push the number 1, then we push string 112, whatever that is. Then we push 0, then we push 0, then we push -1. Oh, we set up a window. That's interesting. -1, 3. Too many arguments to function call, expected 7, have 9. How many did I thought we need? Okay, so we've got window number, then we've got a title. Then just, I guess, coordinates for X and Y. I guess we don't need the -1. Yeah, it looks about right. Sometimes, like, ZBasic pushes -1 to indicate that there's, like, optional arguments. Because it just pops things off the stack to check if it's... I don't know, like, all of ZBasic I'm pretty sure is written in assembly, so it just deals with variable arguments by itself. Okay, then we do ZBasic coordinate window, which is a command which tells all the drawing tools to use window coordinates instead of weird Cartesian coordinates. Okay, G toolbox, clear menu bar, G toolbox, draw menu bar. Okay. Alright, here we have an example of it converting this number to a floating point, then casting it back to an integer, and then calling peak word on it. Jesus Christ. What? Okay. I'm guessing this is maybe like a leftover something, but yeah, converting a number to floating point and then back and then using it as like an absolute address to get something from the Macintosh memory is a bit weird. Okay, is that a... So here's like a special list of special Macintosh addresses. Do we have anything that begins with 28? I think a few begin with 28. Okay, a few begin with 28, but they don't, they haven't been OCR'd properly. That's nice. 2AA, 2FC, 280, value of the count-in square wave buffer. Okay. 2EO, 2BE, 2BA. 944. 260. What the hell could this be? Okay, maybe... Let's just have a quick look in the executor code to see if they have 904 in there. Here we go. So this is all the various bits of memory that executor has to hot patch in order for stuff to work. And we have... What was the piece of cursed memory that was trying to access? It was trying to access 28E, which is ROM 85. Okay, so it's pinging... I remember now, like this... Yeah, we does the same here. So it's checking... I think it's just checking to see if it's the new version of it's like if we look up ROM 85. Okay, ROM 85 is not here because this manual is too old. But if we look up like the follow-up edition of the MacOS documentation, assuming I can find it. A faster way of determining whether the 128K ROM is present is to examine the global variable ROM85. If it's possible, then there's that. Okay, if the high order bit is 0, then if the 128K ROM is installed, Okay, so it's checking the 128K ROM. Okay, that makes sense. Very cursed check for the ROM 85 bit. Okay, so it's comparing that, and then it's checking to see if it's positive. It's positive, that is, the high order bit is 0. Okay, so what does it do? It ANDs it with this and then does a check. So if it equals 0. Oh, okay, and then yeah, okay, this is like another. It does another complicated check to see if we've got like a color screen going on, because I guess by 1987, it then became. Yeah, it then became something else entirely. Oh, sorry, that's right. Yeah, so if you've got a color screen, then this will call the color API to check if... Well, we'll try and set a single pixel on the screen to be a single color and then fetch it, and if it's black and white, then you're in black and white mode. If not, it'll then, like, put up a scary error message. So it's basically this code here again. I'm pretty sure we just got to change whatever the variable is. 372. So that is going to be... Okay, and then 372, 372. Where does it jump to? It jumps to 1E2, which is like all the way down here. C. Okay, so then if it doesn't equal that, then jump to there, and then 294. Okay, and then in here, what do we have? We have this sub 128 8v4 with all this junk in it. So 0, 0, this var I16 5C, this var 16 5A, 2. Okay, then it calls that, and then it jumps to 3E. Else. AB4. 0, 0. This var I16 5C. This var I16 5A 1. Okay, and then down here we've got and now this is the key which fetches what the current graph port is. Toolbox get port, quite important. This var I32 5 F24. Oh, here we go. And then now it's opening a new port based on a chunk of memory in the heap. So G toolbox open port. Actually no, before it does that, it's okay, and this is where it gets kind of messy because actually no, I'm full of it. What we can do is we can go into here. We graph port for 2. Eight F78. Okay, and then these become graph pointers to that. Okay, yeah, easy. Easy. So we can go I32 8 equals address of this graph port 19042. And yeah, like we're keeping all of the original, keeping all these original kind of variable offsets in here so that if there's later code which refers to the same bit of memory, we can go back to this list and think, oh, it's referring to this sub-member of this chunk of memory, and you get the idea. Okay, now there's one more graph port that's at address 0, which I'm guessing is going to be the next one we need to sort out. Okay, and then... Okay, G toolbox clip rect. One 8 EAE. Okay, good. Okay, and that calls this, and then we do G toolbox move port 2. Okay. AP4 0 0 screen height screen width 1. 2 blocks. I didn't mean that. I meant toolbox. This I16372 plus this var. Okay, and this must be the color check. 376. Yeah, okay, because I okay. So it's going to be a similar deal to like in full prologue where we do the color check. What's the color? It's this, yep, okay. So yeah, Fool's Errand does check to make sure that the monitor is in black and white mode, and if it is not, it then runs some code, which for completeness we're gonna we're gonna add in here. Sorry. Eight, 9, 3 equals 114. Oh, and I should have... Okay. So if it does... So it does equal 0, then we go 390. I think UNC4 must be quit. But I'll have to look into that. I should write that down. So 618C, okay. That's fetching the amount of memory that there is. And comparing it to the lowest amount that it can stomach. Yeah, alright. So then 129. Okay, so, so this DFE function must be about printing strings to the screen. Or printing like the little kind of pop-up message to the screen, is my guess. 511. basic finder info. Okay. (7E4). This vaster 588. This var I32 F28. So I'm guessing this is checking to see if we started the game from a saved game or from a because if we started it from double clicking a save game versus double clicking the main executable, if we started from a save game, then this finder info object will point to stuff that's completely different, which is nice. And by nice I mean annoying. Okay, so we got this. We're gonna go to oh, and we're saving this to this var I1644. If g this var stir 588 doesn't equal g z basic stir 126. Okay, then we got some more junk about loading in the puzzles. If this var stir 588 equals gz basic stir 127. Please don't be helpful. Sure, okay. Oh. E22. Okay, and then this var I16 F22 equals this var I16 688. Okay, 1290562. Oh wait, faster 588. Okay. Okay, so inside here we have this stir 588. Oh no, ADC equals this stir 588. Yeah. Twenty equals this 16F2C. If this stir oh wait, this var stir E22 equals 130. Oh. That's interesting. Oh, no, sorry. I was looking at this thinking like, hang on a second. Like, isn't this like the very first function that gets called? But no, this is in code block 129, so we'll be calling the subroutine in code block 129, which is not the first thing that gets called. So I think that's good. I've forgotten what the... Okay, I just realized. Oh yeah, -1 is true, 0 is false. Okay, so... Yeah, so it's designed for these test operators. So in this case, like, BEQ means, is it 0, aka, is it false? Yeah, okay, so if it's false, then jump to here, otherwise, okay, so we got it right, inadvertently. 129.0588. Well, 58C. Equals Z basic stir 131. Like, so many of these are basically just the empty string. I'm wondering if it's worth like hard coding some of these, because it seems a little insane. But I mean, like, there are other times when the string table is used for just like bits of game dialogue. Because like, look, if we look at this one here, like, it's just the empty string, and we can confirm that by going to the string table and looking, and we can see it's definitely just empty. I don't know. Maybe we'll do an optimizing pass later, but Okay, so we're comparing that. And then okay, this oh, I get it. Okay, yeah, I'm pretty sure it's checking this. So it does, like, it's only going to bother loading, like, the start of the game if we're... what's it called? So, like, yeah, we've got this string here, which we're getting from Finder Info. And then we're comparing it to string 126, which is nothing. If it doesn't equal nothing, oh crap, I've like gone way out over my skis. Like we should have closed up all of these brackets at 562. Where the hell was that? Where's 562? Okay, 562 is at this jump 5FE instruction. Okay, so that's good to know. Yeah, right. Okay, and then we've got like 636. Oh, yeah, okay, no, that's a mistake. One, 2, 9, 6, 3, 6. Okay. And what are we pushing here? We're pushing this F2E, which is going to be like the file ID. And then... wait, negative the file ID? Alright, this function is new, so we're going to look at the Z basic manual, assuming I can find that. Okay, Macintosh. Also see files $. Okay, is it just gonna be the Macintosh appendix? Okay, disk file. Open, close. Where's file $? Oh wait, I've got the, I think the Macintosh manual, sorry, the Z basic manual that I'm using is too new. There's that one, and then there's this one. Here we go. Returns the file name and volume number of the file selected by a user for saving or loading. Okay. The beginning number expression designate what information is being requested. Okay. Returns the files and folders located in the root volume designated. Volume number is also returned. Okay, so -1 is referring to the root volume. Okay, so it's loading a file. This could also be like the multi-disc stuff, like maybe it's like waiting for, like it's, this could be like if it can't find fool's puzzles, then it tries to do its best to spack around that. Let's just type it up and see where we get to. This var i16 e20 if doesn't equal, oh no, equals 0. Okay, then we push this vars to F30. Okay, if this okay, so if this is true, then jump down to here. Okay, so we're still good. This feels kind of repeated. I can't quite put my finger on why. I mean, like, it's calling this again. Like, is this maybe... Maybe I screwed this up and it's meant to be like an else? But, like, they're both checking to see if the damn string is empty. So... I don't know. I don't know what's going on. Oh, is it retrying maybe? Oh, right, yeah, because there's a... Okay, yeah, I get it. Okay, so then this boots it, so it's like it's a while, or a do while loop. That's great news. I love do while loops. So... Then we're here at 628. Oh, okay. Yeah, it's technically a for loop. Five AC. Okay, that explains why it kind of looks so weird. 4. This equals 1. This var I16 F2 E is less than 3E8. This var I16 F2 E plus plus. Okay, and then that breaks out there. And then we're down to here, 636. Okay. Yeah, alright, so this is like... I mean, we don't have to implement this in full, but... Yeah... I'm guessing most of this was just going to end up being commented out. Because, I mean, like, the original, it would call the Macintosh Finder to fetch a file, and in ScumVM we don't really have that, because it's either there in the file system or it's not. So we'd probably just make this a hard break. But just in case, oh, that's okay. That's actually a good point. Now that we have this file here, any significance to 772? No. Oh, it's minus 772, so that'll be like an application global. So some Z basic thing. Okay, where does it knock us back out? 129.06 EA. I'm guessing this must be if we cancel, then it, because I think UNC4 is quit, because it's using another area which would suggest quit. Oh, okay, this is like an infinite loop to check if... Yeah, okay, so it's actually going to be a do while. I'll just double check. So 650 is... yeah, just before the text command. Yep. Oh, and that'll be 61030, so that'll save something about the res file. Okay. It returns a file ID. Okay. Oh, I think that returns a number. Okay, okay, so this is probably going to be another loop. Yeah, as expected, so we'll just go for int I equals 0, I is less than wait, okay. What? Okay, is greater than or equal to 1. That doesn't look right. That looks a bit off. But we'll do it all the same. Okay, this 192CO. Okay, yep, so it's buffering all the pictures. So because this is a game that is loaded off floppy disk, it'll try and fill RAM with a bunch of image data from the resource fork, which is what this command does. Plus 54. Oh, because it's unsafe. Okay. Whenever there's like a mention of like push unsafe, that basically just means increasing the size of the stack, which is usually a prerequisite for these toolbox commands. So you just ignore it. Okay, and let's crack open the emulator and see exactly what resource it's meant to be pulling. I'm imagining it's one to do with the title screen. Mac. Here. Okay, so if we move Fool's Errand into here. And then look at the pictures. Okay, there are no pictures in... There are no pictures in here? Well, alright. How about the puzzles file? Yeah, okay. So this is like... So we've got all the tiles for the sun's map, which is kind of important. There we go. Alright, so we've got some interesting stuff here. What's the offset? 54. Okay, and it starts at 84. Yeah, okay, so this is the scroll background. I don't know why it's like a loop of 1 though. Possibly because they copy pasted this function from somewhere else and it was already in a loop. Okay, so it gets the picture. And then it immediately... Oh, right, okay. Detach resource basically just means to tell the Macintosh toolbox that ownership has changed. Because normally when you call get picture, the handle is owned by the toolbox and can be like queried with a bunch of the other commands. But detach resource basically means don't free the memory, but instead just remove the ownership link from the toolbox, which should be fine as long as there is like it's all reference counted on this end. So as long as there's a reference held to it, we're good, I think. And then we go. Yeah, it adds 1 to the counter and then it compares to see if we're greater than or equal to. Which is gonna be all the time. So that's a very weird place to put a for loop. Okay, and then we go Z basic. Okay. But I mean, this is good. Like, if this all up until now works, we should at least be able to see the title screen. Okay, that blitz it to the screen, I think. And then... Okay, and that... that right? That seems like the arguments match. GZ basic get. Wait, what? Oh, no, I've got this wrong. So it's not a BCD, like it's R5DF. Yeah, it's a bitmap handle. There we go. B3EC. Screen width, screen height. This BMP 109 DC. So like these get commands take a copy of stuff that's in the viewport and save it to a bitmap handle for later, which is mostly, I think, used for overdrawing stuff. I16 68A equals 0. Okay, this is probably another loop. Yeah, okay, it's another loop. Eight, four, 6 129 888. Yeah, okay. So 15. Yeah, okay, I got it around the wrong way. So it's less than or equal to 1.
Up. More cathedral dumping in Leicester.
Well, there was 2 of them, 2 bishops, become.
A46. I16 484. Zero. Oh wait, no, this is put. Which is just X, Y, and then the bitmap. Yeah. And then this sub 128 3DA. 1 for F. This RB3. Interesting. Oh, okay, it's like getting... Seems to be just copying part of the screen and then overdrawing it and then writing stuff underneath. Like maybe... This is... I don't know. It will depend what's in sub 128 3DA. Okay, so we've got... Okay, that goes back to A4C. So we've got 1 put command, 2 put commands, and then a picture command. Okay, looks like a for loop, which... Oh, it's a big for loop. It's a very big for loop. Hey, alright. Well, we've already got stuff that's drawing on the screen. How about we, like, put a... Why don't we just kind of, like, say... This is the end for now. And see if we can get at least, like, this much drawing. So that in itself is going to be a bit of an ordeal just to get...
Yeah, with whiskey there.
Goodness.
Check this out on replay.
Yeah, okay, so we've added a whole bunch of new state which we've got to keep track of. That's fine. No declaration matches this. Well, we'll see about that. Uh, 37A. Yeah, and being a basic program, it's all global state. Obviously, after we've translated it all, we can go back and convert this to be on the in the function, therefore like not on the heap like all this stuff is, which should make it a lot more readable. But that's going to happen after we've translated all the source code, because otherwise it's going to be a nightmare. Like, we're just going to have to, yeah, you need to translate all the code first before you can go ahead and like start refactoring, at least in any serious way. Okay. So we gotta add... Okay, where's my... Yeah. Oh, interesting. Okay. Draw menu bar is not part of that? Okay, well... Yeah, okay. Draw menu bar, draws the menu bar according to the menu list. Okay, ooh, incompatible type. Oh, I get it. I get it. I forgot. This is an array of strings, which are currently being set by this. Okay, so 1A, 8D8. Okay, so did I get the width right? Because I'm guessing this is going to be the start offsets for each. Okay, that's 66 each. 90, yeah, okay, that's right. Okay. And that's why it's important to not just blindly make variables, to kind of progressively go through and check that they're in the right spot. Because like this function here, which I'm pretty sure draws the strings to the screen, is going to iterate through the what expects there to be an array there, and if they're all individual strings, then that becomes a massive pain. But if they're in a list, then we're good. Okay. Oh, we'll just add a variable for it now. Okay, then we got like okay, then we got the files command, which I've not set up. What does the files command return? Returns the file name and volume number of a file selected by the user for saving. Okay, so yeah, all right. So it returns the file name and it passes back the volume number through that that pointer argument. That seems legit. So now we're just gonna make a stub. Prompt. File name. And then seems about right. Except volume. Returns the file name and a volume number. Okay, that, like, I get that. Then why was the last argument to this a string? Did I screw that up? Where's the disassembly? And about 5/8C. E20. Okay, where the hell? Okay, so E20 is it's an I16. I'm pretty sure. Yeah, it's got to be because there's only 2 bytes for it to fit into. I16 E20. Yeah, and it does all that. Oh, okay. I made a typo here. That's E20. And then it checks F30, which is legit. Oh no, it's a common E30 string faster F30. Interesting. Okay. Cannot bind non-const value full handle to this. Okay, because it modifies the handle. Hey, Walton Trum, how's it going? We're so close. Once we get these compiler errors done, we should see something on the screen. It won't be good. It won't be, won't be nice, but we'll see something. Okay, crap. So just a few more variables. That's all we gotta do. Just a few more. 372 37C 32 16 37C, because that's from the memory functions. Oh, I should learn to type. Okay, another string. B3EC.
I started thinking about my mom and home, how much I missed it. And then I started.
Oh, Walton Trust says, never heard of the game. Was it a Mac game? Yes, this was originally released on the Macintosh in 1987, and there were ports made for like MS-DOS and Amiga, which was all based on the MS-DOS port, but they're not as good. The graphics don't look as nice, in my humble opinion, and the author, Cliff Johnson, basically said, you can play these, but they're nowhere near as good, and you should be playing the Mac version. So we are targeting the original Mac version. You know what? Let's just show off the introduction, because the introduction kind of gives a good vibe as to like what the game is. Let me just swap out the intro exe, which I've actually got building and compiling properly. Crap. Okay. How about I just cheekily put this in the stash and then build it, and then go into so yeah, it's a puzzle game, which is kind of got like a quite long and involved narrative to it, and you can like join in. You basically join in the game at like, what's it called? I think that should be the right. Yeah, there we go. So essentially, yeah, you start at the beginning of the story. You get like a few places in the middle of the timeline, and each of them has like a puzzle that needs to be solved, and it's each time you solve a puzzle you unveil more of the timeline until eventually you've got enough to kind of complete the puzzle at the end of the game, which then leads to the conclusion. And yeah, the story is kind of based on the tarot, so like so we just saw the High Priestess, which is one of the cards, and then we have the Fool, which is like the main character and also one of the cards, who is then now talking to the Sun, who is another quite important tarot card. Yeah, and it's all about this, and yeah, this Fool is kind of on a quest to recover the lost treasures of the land, but has no idea what the hell he's doing. So the son gives him a cool map to figure out how to do it. And then as he kind of goes on, he realizes, oh wait, there's like some kind of treachery that has corrupted everything in the land, and I need to solve a bunch of puzzles to put things right. But then even after that, you don't have the treasures. You got to like sort out the end. You know, you got to figure out the end game puzzle in order to actually find the treasures. So yeah, that's the introduction. We managed to get that we got that working by porting over a bunch of Z basic code, which is what the game is written in, and implementing like a lot of the Macintosh drawing routines using the ScumVM graphics stack. We didn't actually, like, it didn't take very much. It took like about 3 weeks of effort all up to just port that over, and now that we've got like, I consider that a pretty good proof of concept that this is going to work, so we are in the middle now of porting the game proper, which contains, the code module for the game is massive, but we're just trying to kind of get like the first bit of the game rendering on the screen at this point. So that's kind of where we are now. Okay, now that we've done that, I got to git stash apply. Oh crap. Git stash apply. Okay. Weldentron asks like a wrapper for ZBasic. Not quite. So ZBasic is compiled basic. Like that's one of the kind of big draw cards, is that it compiles to machine code. So the game is still actually Motorola 68K assembly language. However, when you look at it up close, it's not very optimized. It's very clunky. And that's actually good, because then it means that we can read it and convert it into the C++ equivalent, because that's what ScumVM is written in. But you can see that like it's not properly optimized. It only used like a couple of the registers, and it calls out to a bunch of these methods, which are like ZBasic native methods. So this is just a very crappy Motorola 68K disassembler that I made, and it just has some mods to say, okay, it's using this, like it has the addresses for where ZBasic stores all the variables hard-coded into it, and like the ZBasic function names that I figured out are also hard-coded into it. So yeah, we're just going through and converting this to God's own chosen language, C++. Yeah. I did initially consider like, could we make this like a bytecode interpreter for ZBasic, but it's too. Like to do that, we'd pretty much have to like make a 68K emulator and embed it in there, and I don't super want to do that. Like, because at some stage, like, the advantage of porting it to C++ is then you can extend it, I guess. You can do stuff like translations and fixing bugs and other enhancements, and it's nice to be able to do that when you can just see the code rather than some kind of crazy interpreter for the code. Also, if I recall correctly, there have been engines in the past in ScumVM which did like the interpreter approach for like another architecture, and they've since been removed. So yeah, so all good excuses for porting to C++. Okay, so we've got all our junk back, and yeah, so now that we've done the porting, I just got to go through and add in all the variables that have now kind of shown up. Because from the disassembly, you don't really get typing that's kind of inferred based on what the variable is used for, like if it's used as a number or if it's used as a string, and then you've got to figure out the boundaries yourself. So we're just declaring variables as we go, because there's one global variable store for the entire program, pretty much. And then, yeah, once all the code is ported over, then we can do the the fun cleanup part, which I'm super looking forward to. Ugh. Okay, F2C is... Tell me about F2C. Okay, F2C is used as an integer, that's fine. So we're keeping all the original variable addresses here in the name so that it makes it easier to cross-check if we screwed up. That's interesting. So F2... So this is definitely getting a word back from this function here, 128.5fe, but I've written it down as being int32, which is pretty deliberate usually. 5fe. Yeah, so we move a 16-bit int to the output and then it gets extended to be extended to long. So it is... Yeah, I mean, okay. It's technically only ever going to be an int16 though. So I think we're probably safe to say that function is going to be... an int16. Yeah, because it's a volume reference number. Okay, and then that's used to then check to see if like the file is there and stuff like that. Oh bollocks. Okay, where were we? Invalid conversion from int to bool z basic window type. That's okay. That's an enum that we can fix. Full game is no member var i32f32. Okay. Okay, but this is fetching information from the finder, so it should be okay because it's technically initializing it. I think it's res type. Okay. No, it's not a res type, it's a file type. OS type, sorry. That's the one. And then In Z basic, we should really make this of type OS type. Okay, 9EC. Can't convert integer to string. That's not good. Did I get the calling convention around backwards? I might have got the calling convention around backwards. Oh no, E20 is a new thing. So it's expression something then volume. But it can be variable arguments, so no, it should be 2 strings and then a volume. But you can, I suppose, give an empty string. Yeah, so we'll push null pointer for that. Okay. So -1, then the blank string, then the number 0, then that pointer. Okay, so we'll just say common. Oh, okay, I screwed up again. Where is it? It is... okay, what's in string 132? Okay, string 132 is blank, it doesn't matter. Yeah. That's fine. Mm-hmm. One, two, two, one. Dick. Value not ignored as it ought to be. Cannot bind... Okay. 643. Oh, because it's a void. That can't be right. Yeah, right. Definitely doesn't seem to return a value. So what goes on there? Oh, 718. Okay, and then just a little bit later, after open res file and use res file, it then calls this. Oh, and then it saves the result to DO. So presumably PB set volume returns something. That's kind of weird. Okay, 128 64C. Yeah, call set vol. Set vol sets the default volume to the mounted. Oh, it returns an OS error. Okay, fine. So we'll fix that. Does PB... Okay, get vol also returns an OS error. So I've got screwed that definition up. Possibly because I was like doing it in a hurry. And we've got SF get file. Okay, SF get file and SF put file don't appear to return an OS error. It's just these two. I think O is fine. Okay. Okay, cannot bind non-const value of full handle to detach resource. Okay, so given a handle to a resource, detach resources. We'll just make a copy. That's fine. Okay, then last bit. Okay, so this is referring to the 2C4. Okay, so it's referring to index 1 of here. Yep, okay. In instantiation of common share pointer here, cannot convert image pic decoder constant to... Oh, okay. Because... Oh, I see. I see. Because I did it the wrong type. So... It's not actually a handle, it's a pic handle. Which is different. Oh. Oh, I see. Oh, I get it. I get it. I need a man nut. Yeah. So there are some... So like, in Macintosh Toolbox parlance, a handle is just a pointer to a pointer. And there are certain functions which expect... You know, they just treat it as a generic pointer to a pointer. And others which do special things based on whether or not it's one of the types that it knows. So like, get picture returns not just any kind of handle, but like a handle to a picked instance. So we need to like overload the function in resman to like release resource. Yeah. Oh, interesting. Okay, no, I've already overloaded it. So we do have a pick handle variant of this. Oh no, that's release resource. We need to do the same thing for detach resource. Wherever the hell that is. Yeah, okay. So we'll just... Okay. Yeah, so I think detach resource removes the picked key from in here. Yeah, and then in toolbox, detach resource. Alright, dope. It's built. It'll probably just rocket to the end, and we might have to add in a few. It'll either rocket to the end or it'll get like trapped in an infinite loop somewhere. Either way. Okay, so we've got a little message here to set our monitor to color black and white mode. Oh wait, no, hang on. It's because that's just the introduction. That's because I have not moved the the game into the critical path. That's probably why there are no more compile errors. Yeah, okay, so now there are a couple of stub entries that we've got to add before it'll actually link. So what do we have? We have draw menu bar. Okay, mea culpa, we don't implement that yet. Frame rect, frame arc, erase run rect, draw picture. And there was one left, which is a subroutine. Okay, 2808. Oh, okay, and the files thing in ZBasic. That's it. That's the last one. Okay. It builds. Okay. Let's see where it crashes. Will we get to see anything on the screen? I mean, we damn well should. We saw, we got, like, the code that is going to be run. Okay, we've got, we get a little box. And where is this getting stuck in? It's getting stuck in 1163. Oh, okay, it's whinging about the color mode. So, I'll just comment this out for now. Because I want to see pictures. Just a picture. Okay, got a null pointer. That's not great. Oh crap, okay. It's actually been quite some time. I'm really going to take a quick break. I know it's unsatisfying to kind of do it just as we're on the precipice of victory, but I'm also kind of peckish, so there is that trade-off. I'll be back in about 5 to 10 minutes. Go stretch your legs. Go fill your glass. Do whatever it is you need to do. I'll see you in a bit. take a quick little look into why it was crashing. So it would appear that the so it was crashing when we tried to draw a picture, and then working all the way back, it looks to be that well, we got a null, and I think it was, oh crap, I closed it. Initially, yeah, I thought it was because we were missing either one of the surfaces was null or the graphics port was null. And yeah, I fixed the graphics port problem, but I think that we've still got an issue with the surface being null. Kinegos go, oh hey Kinegos. Kinegos says, welcome back, how goes the Wacky Toolbox emulation? We're close. We're close to getting like something to render on the screen for the actual game. Except we still got some crashes, so we're gonna figure that out. Where's it crashing now? Oh, it's crashing because of the put method. Excuse me. Oh, I see, okay, because it's using this handle for a bitmap, and we have not defined anything. We have not done anything with that bitmap handle yet. Okay, how did I do in the prologue? Because the prologue also had... so like this is like one of those cases where we're having to like take some creative license with the original code, because the original code just takes a big chunk of memory and then writes to it and pretends that it's a buffer type, but we're using the native surface type, which then means we need ahead of time to be able to define how big it is, which is kind of a big deal. So what was the bitmap type? Okay. Right, okay, so straight off the bat, we fetch whatever the graphics port bits are and then use that. I mean, that's a pointer to it, isn't it? How about these ones here, like 36 and 40? Oh, sorry, 40. 40 and 4E. Oh, I see. Okay, because that... Yep. So we initialize this to start with. And I don't think this is based on any code. I think this is just inferred based on how big the array is. So we're gonna have to do something similar, I think. Okay, we got this fun array full of... Oh wait, no, those are all handles. Okay, this is also a handle. So is there something in the code which is meant to be defining that bitmap and then we're missing that up? Or we just missed that piece of code? 1263. Because yeah, here, by the time we reach here, this bitmap handle needs to be real. 5DFC. Okay. Oh. Okay. So if we look at the gap here between 5DFC and B3EC, how many bytes is that? It's probably going to be 22,000. B3EC minus 5DFC. 22,000. Okay, so we would need to just put some code in the init function which defines a surface of that size, because it's literally just pointing to raw memory. That's okay. We'll just go. Okay, so 5DFC B3EC. And it's what? 512 times 342 divided by 8. Yeah. So full screen. Oh yeah, okay. Oops, yeah. Graphics, merge surface. What was the other one? 1090C. Okay, that's good. Now, what was the other place which had bitmaps? Oh, it's just those four. Okay, easy. Oh, and the rest are like pick handles, which are 4 bytes. Okay, I can live with that. What? Okay, so it made it past... It made it past all the problems, but it's not showing anything. It should be printing, like, the nice... It should be printing the nice scroll on the background. Why is it not doing that? Okay. Okay, so it's calling draw picture. It's got all of that, and then it calls copy bits. Right, and then it craps out because there is an empty graphics port. I'm kind of concerned by that, because by line 1262 we should absolutely have a graphics port. Okay, so we've got like, maybe I should call set port as well. And I mean, at some point it must be set up properly, because we were able to see the warning message. Okay. Hold on. So this drew to the screen. And this is at like line 1164. And then now we're all the way down down here. And suddenly there's no viewport. Yeah, 1262. Okay. Ah, crap. No, mistake. 1161 I meant. Because something must be setting the screen port. Oh, okay. So the port is set to null. Oh, is that something that I got to set up here? Or just something that needs to be... Is it something that gets set up in ZBasic? What am I missing? Okay, no, so this is the ZBasic stuff which like opens the window and sets the default bits. Nothing about it setting the default graph port, though. Actually, no. What am I saying? What am I saying? We have get port and open port. Does open port also do the equivalent of set port? Did I just not read that instruction properly? Okay, procedure open port. Allocate space for initialize the graphics port. The window manager calls open port for each window it creates. Okay. And there's like the set port procedure. All quick draw drawing routines affect the bitmap of the current graphics port. Okay, before drawing to the window, listing 2 calls the set port procedure to make it. Okay, I see. Okay, so it stores the original window graphics port to F24. Then it does all of this stuff to like open. I mean, like the implicit read I'm getting from here is that open port does set the current graphics port. So it's important that we check that that's true. Hey Code XYT, how's it going? We're just kind of reading between the lines of the documentation to try and figure out all the minutiae of how Macintosh graphics drawing works so that we can recreate it exactly. Okay, so this code only makes sense if open port sets the current graphics port so that port size, etc., all does what's expected. Okay, and then that would leave this final graphics port as the one that is currently selected, which you could do worse. You could do a lot worse. Okay, let's see if that... Office... Yeah, okay. We'll... Actually, more importantly, we've got... Okay, so if we look at... Okay, so by default, when you open a graphics port with open port, it uses screen bits as the bitmap, which is good. So that should work, I think. Should draw something to the screen at least. We got a scroll. We got one frame of a scroll. Oh, that's right. So when you open up the game, the scroll is meant to unfurl down, and then you see the content in the middle. So we've got, I mean, halfway there. We've got the scroll appearing. We just need to coax it into. Also, apparently, we're filling the screen with checkerboard. Apparently, that part of the code is working. Oh, I see. We're stuck here in. Oh, I think I understand. Okay, so if I were to put in a breakpoint right here at like line 1275. It's probably going to like just keep rattling on after that. Which means we've got to do more porting if we want to see more of the more of the title screen. Yeah, okay. So that scans. Oh, and we have to implement put and get, which we currently don't have. I thought I implemented put and get. Apparently not. Oh wait, because this is the one that stretches. Oh no, I haven't implemented put. I must have implemented get. I refuse to believe I did not implement get. Because I can't. I did not implement get. Okay, that's on me. But we should be able to do that pretty simply. So zbasic h. Okay, let's look at the zbasic API then. Okay. Oh my god, so no. Here we go, index. Put EO6 or 306. Okay, it's important to see entry and a get for more information. With this version of zbasic, put as another optional parameter. Yeah, because you can scale the image. Places the graphic bit image stored in an array at the get statement to the screen position and coordinates by here. Yeah, okay, we can do that. So put source bitmap desc bits is going to be, I guess, the screen. Oh, no. This is going to be the destination rect, isn't it? So the source rect is going to be source get bounds. And then source mode is going to be just source copy and null pointer. I think that makes sense. But then okay, but then we got the issue with get, right? Which is that it's all fine if it is the size of the screen. But I don't think it we're gonna have to look at the let's say if an array is been used, you must specify the index number of the array. So you basically allow to store bit images in any variable type as long as there is enough inout memory is available to do so. Okay, and oh, you can specify the mode. Interesting. So actually my I remember now. There was 129. Because in here there was an extra argument that I just ignored because I assumed that it was not relevant. Yeah, okay, so we've got 0. So that's going to be that's going to be the mode. So we better add that to our function definition for it to be good. So we're going to here. Okay, and then this becomes mode. Loads of problems. Okay, now because of all of that, that's okay. We just have to have a look at what bits went bad. So this call of the put was 0, this call of put 2 was 0, so these are all case source copy. I think. Oh wait, okay, so we've got mode. Maybe I've got to look at the Macintosh manual. Tell me about put and get. Okay, so that's page 47. Okay, put. Okay, put is how. So there's ZORs of the pixels and the picture of the background. So it's ZOR or an AND. So we should probably test that against eBasic to figure out which one it is, but that was wishful thinking. By virtue of it appearing first in the list, I'm going to assume that this is 0, and this is 1, and this is 2. Okay, and in here, we just go to basic put mode. I think it's this. Okay, that's put out of the way. Get, on the other hand, that's gonna... Okay. The two commands get and put bit graphic images to and from the screen. X on one of the coordinates to the upper left corner of the screen graphic. You will store the image in memory area occupied by array. So if we were doing... Yeah, if we're doing the long... I see, okay. So I should probably... Okay, date function. Get statement. Wow, what are the odds? Okay, failure to dim enough memories may result in unpredictable system problems, aka scrubbing over memory and wrecking everything because there's no memory management. Or no, what's it called? Virtual memory / paging. Well, sorry, there is paging, but there's no like memory protection or page protection. You can just scrub over whatever you want. It's a good system. Okay, with this version of ZBasic, put as another optional parameter. Okay. So this image is normally stored in memory specified. Oh, I see. Okay, so get always has to, you always have to specify both dimensions. That's good. That's really good. So then we'll just resize the image every single time. So to fit, because I'm pretty sure that it's storing the equivalent of like, it's, you know, it's updating like how much space the bitmap structure is using. So we'll just go dest source rect x1 y1 x2 y2 dest create and then we do toolbox copy bits. How did I do it for put? Oh, toolbox default bits. No, that's not right. I'm guessing it would be the current graphics port. Okay. Okay, then we'll go back up here. Okay, source mode would be... Oh, is mode also... Oh no, no, no. We'll just use k source copy. Null pointer. Okay, that's get implemented. Okay, now it's whinging that... Okay, put... Because there are a couple of cases where I screwed that up. There's 00E6. Yeah, okay, let's get... Okay, and then that uses put, so... It's using Zor, would appear. Actually, no, maybe 0 is copy and then like Zor is like yeah, I've changed my mind. So we go k put copy equals 0. And then that matches the graphics, the Macintosh graphics ones, I think. Full. Oh, not quite. Copy is 0, or is 1, or is 2. Vic is 3. You know, okay, let's be smart about this. Oh, that'll do. Okay. Okay, yep, that's 0 again. That's 0 again. All those are 0. So that'll be copy. Okay, source copy. Okay, source copy. Oh crap. I can't do that. It's gotta be k put copy. Right, and we still got some more. We've got like 5, 7, 8. DFE is at... The hell is... Where is it? Okay, DFE starts here, and then eventually we should see some puts. Okay, yep, 0. Wow, it's like all the way at 2526. What's going on there? Okay, put copy, put copy, put copy, put copy, put copy. Oh crap, was this... Oh, it's the prologue. The prologue has problems. I see. Okay. Oh, yeah. I better... Oh, actually... Yeah, I better double check that it's okay. Oh, come on. Where was it? 1310A7A. Yeah, okay. That one's fine. It's just a copy. Okay, put copy. That's also fine. Yep, that's also fine. Okay, good news. Oh, that's all it took. Let's... Okay. So if we start it up again... we might even see the scroll move this time. Because I think that's what the puts are for. Just kind of like copy pasting the same piece of screen over and over again. Yes! Okay. So that moves. Where are we getting? Oh, okay, and we're getting stuck in the same spot. So I think we'll just double check, but be right up here at the boundary at 1275. Yep. Okay, cool. And this bit of the screen, I think, is intended... this bit of the screen is for the menu bar, so that explains why there's a gap up there. And I think, yeah, it does scroll down all the way to the bottom. Cool. So let's commit what we've got and then get back to just porting more of that intro function. Okay. So, where did we end up? We ended up about here. Close this window, or, okay. Alright, and then we just back to it. We've got a, okay, this var 16, 68a equals 0. This okay, so this is going to be another for loop. So we go... that's right, this was the... oh, okay, that's actually a tiny for loop. For int I equals 0, I is less than or equal to... because then it loops around here. 129091A. Okay, and then that frees that handle. Okay, there's gonna be another loop. So where's the... Okay, here's the end of the loop. So it's... This must be all the tiles for the sun's map, I'm guessing. Because they were all at the start of the... Where it made me let it go? It's here, okay. Yeah, okay, so... 1 to hex 53, which is 83. Yeah, it's all tiles for the sun's map, so I'll say... I'll just write that down. Okay, do I even have... I don't even have a reference for that. Is that right? Oh, yeah, okay, so I should... Okay, so 53, that's 83. Oh, okay, there must be more. That's okay. But we know there are this many map tiles, so good enough, I suppose. So we've got this. Just in time says Clang D. Oh, you mean the code completion engine? Yeah, this is NeoVim running with COC and the Clang language server, I think. And it is currently really... I don't know what's happened, but at some point it's suddenly just decided to kind of start auto-completing numbers, and it is really irritating. So maybe maybe once I kill the stream, I'll have to search around to see what gives, because I hate it. I wish it wouldn't do that. I'm pretty sure it wasn't until very recently. This 516 68A equals 3C. Okay, 56. Ooh, alright, that's like the Wadget Eye from was it? Yeah. Just in Time says, people always side-eye me using NVIM at work. Oh, as you work in AAA. Because Visual Studio Writer is so common, but I love the no distraction. Yeah, I can't abide by Visual Studio. I've tried it a few times. It's you can do worse, don't get me wrong, but I think the bit that kind of gets me the most is the build system. The build system I do not like in Visual Studio. I mean, mostly I generally only ever have to use it if I'm like building like, I mean, the only time I ever really like whip out Visual Studio is when I need to do, say, like Windows CE builds, because like, I don't know, occasionally, what's it called, I don't know, like I have some barcode guns and they run Windows CE, and to program them you need to use it's like .NET embedded. That's, I mean, you can use C, but I mean, like, .NET Embedded does like 90% of everything you want, so it's fine. But obviously, like, in order to do anything in that world, you kind of need to run it through Visual Studio. And when it works, it's great. When it doesn't, when it doesn't work, you kind of consider just wandering off into the ocean. Maybe never, better yet, just never touching a computer again. Oh, Just in Time says, I mean, I have to use Visual Studio to build or debug, but I run NeoVim to do the actual navigation work. Oh, because Telescope is much better. I might actually look up, what is Telescope? I don't think I've got Telescope. Oh, okay, it's like a fuzzy find. Okay, so it's like a fuzzy file name finder. Interesting. I'm not sure what I use. I use whatever this side pane is. I guess it's Cock Explorer. It's okay. It could probably be better. I might look into Telescope, because I don't know, maybe I'm just putting up with it. Maybe there's a better way to live. Okay, okay, so it's loading the sun's map tiles. Then it's... Okay, then it's loading a single picture and detaching it. Oh, Just in Time says grep integration. But now I just get Claude to tell me where my shit is. The tokens ain't coming out of my pocket. Well, as long as it's not your nickel. It's... yeah. It is funny just to kind of like... I don't know, I'm very much kind of like not an AI person, but it is fun to just kind of read about what's happening in that world, especially with like, was it Maltbook, which is that weird social network that people could like sign up their bots to participate, to like, you know, cosplay as being people, and then you read the post and it's just kind of, it's like a combination of a 14-year-old pretending to be the computer from System Shock and startup founder brain rot. And then you learn that like some people accidentally lose like hundreds of dollars worth of money because of wasted all the tokens. And it's just like, what are we doing here? Who is this for? Is this just so that, is this just because you feel like a great need to prove that this is worthwhile and useful? I don't know.
And Kawasaki making use of more than the meat, blood, and organs, the egg.
Blood and organs. Racing the Beam says, I just took my first steps with Claude this week. Burned through my allowance in 30 minutes and was left with a half-baked unfinished feature. Probably a skill issue on my part, but I'm so far underwhelmed. I'm not sure, sir, it's a skill issue. It sounds literally like how it's, you know, it's designed to basically get there by scraping against the guardrails, and quite often or not, that's very wasteful. So I wouldn't blame yourself. It's just, it's designed to waste money. In every sense of the word, it's designed to waste money. This var i32c. Okay, that's a feature that we don't have. Race of the Beam says your Instagram feed gives you major FOMO and I've fallen for it. Why are you fearing of missing out? What are you missing out on? Please, I'm I'm really keen to hear what gave you FOMO. 'Cause yeah. I don't understand. Okay, tell me more about this icon. Ah, okay, so it's like the little icon of the sun's map, or the scroll. Just Time says, I'm being forced to use it currently. There's a skill curve to managing the context of memory. A well done trimmed Claude MD can do wonders. I get to see API costs. I've been using it as a first pass reviewer for features I work on, and after the initial $8 of codebase exploration and manual tweaks to the MD, it gives good feedback on existing style, formatting, and paradigms. I'd like to stay employed, so hopefully you can continue being a tool in the belt and not a cheaper, less outsourced thing. Race of Beam is, it's just constant AI doomerism, people claiming to build insane stuff in 2 weeks. Yeah. It's definitely kind of, there is this kind of like weird thread of people, especially when it comes to like code, building stuff with AI with code. It's always, it's either like I built this like script, you know, this little script tool which I didn't have, you know, I didn't know how to do, or it's I built this massive colossus which just burns, you know, which you can just shovel coal into and sometimes get out something useful. Like there's no medium system. And I mean, it's, yeah. Kinnick says, AI is the biggest fucking source of drama in software dev to date. It's, yeah. I don't know, the few... I don't know, my current policy on AI is no thanks, just because it tends to not well, a few reasons, especially like one is because I mean, I do kind of see it as ripping off the commons like a lot. As someone who contributes a lot of software into the commons with the only stipulation being attribution, and they can't do that. Like, I refuse to believe that there is not a technical reason why they can't do attribution for source code that they lifted. They just don't want to. And as a result, like, you know, I'm hardly going to go and endorse something that kind of rips away my attribution. But I guess, like, on a more kind of lower level note, like, every time I've seen an AI build something kind of massive, or even just medium-sized, it just looks very unmaintainable. Like, the amount of effort that we require to understand it and I guess architect it to be something sensible is probably on, you know, probably take about the amount of time to develop from scratch. So, you know, I don't know, I've been kind of off put by that. Oh yeah, crushing sickness has got to make it maintainable in a prompt. You got to say you are a, you know, smart, well competent senior engineer who never ever deletes the production database. That would be the worst thing imaginable, but does write really cool code that is easy to read. It's, I don't know. It's hard. Oh yeah, Race of the Beam says it'd be Steve Yeager if you're, but yes, the Gastown guy. Gastown is very much like the end, like it's very funny to watch him kind of like at every step say, no, you don't understand, like this is only going to be for you if you're already juggling like 8 Claude Code accounts so that you don't get rate limited. And also you don't worry about where the money comes from. And like then you look at it and it's just kind of, oh, I don't know, just like a world record for waste. Oh, Justin Time says, I think what's happened is that Claude has given people who either A, couldn't, or B, wouldn't spend the time after to learn code the opportunity to learn the codabucks. To earn the codabucks they've always learned about. Yeah, it's... What they don't realize is that as it proliferates, the codabucks goes away because our time is less valuable and cheaper. Yes, it is very much kind of an engine for de-skilling in the vein of the McDonald's, you know, like the ovens in McDonald's, kind of. However... I don't know. I feel, though, that that's kind of... That's definitely devastating if you're just trying to break into the industry, or if you're kind of at maybe kind of like a midpoint of your career. I mean, this may be kind of like a little bit big-headed, but I get the feeling that we've kind of been here before. Like, this isn't the first time that we've had a massive wave of... I want to say poorly architected applications being created at a tremendous rate. And on the other side, there is going to be a threshold at which, like, I don't know, I'm reasonably confident that if you're very good at troubleshooting and know how to kind of debug things by going into the woods with a pointed stick, you will have so much work in the future. It is just going to be all upons as every... Because, yeah, there is definitely a threshold at which the AI, you know, the current recommended approach for fixing a problem is to get the AI to fix it. And then you just keep doing that, and then eventually it reaches a size where for everything the AI fixes, it also breaks 2 other things. And then because it's all kind of like spaghetti-ish, you know, the barriers for entry for modifying it get higher and higher. And the other thing that kind of slightly worries me is that people seem to be getting the large language model to create documentation as it goes. And I don't know about you, but when you read it, there's a kind of uncanny valley effect where it may be telling the truth or it may be telling crap that it made up. And I don't know. unless someone has reviewed it, it's worse than useless because you don't know. You don't know until you kind of like run into it face first. Oh, Race of the Beam says, that's my biggest open question so far. So in a big project, you build a mental model of the project over time, which involves implicitly through the process of building. If AI generates everything, the model doesn't appear. I do wonder if most of the people who are raving about it just weren't that good to begin with. I think that the people who are raving about it are just kind of very excited that they, you know, because it is enabling. It is fun to just kind of like say something out loud and have something coming out the other end. But if you haven't learned the process of software design to begin with, and then you're just kind of given like a big slab of code, and like your only option then is either to, I don't know, to ask the AI to do stuff with it, then where does that get you? That doesn't really kind of give you, I don't know, it doesn't really give you the skills you need to even like from a perspective of how to prompt the model. Like if you haven't been there before, you don't know kind of like what kind of pitfalls you can fall into, or like how to get the LLM stuck out of a rut before it burns up all your money. Oh, Just in Time says, I found it's been very empowering to non-technical people in my industry, so like producers, artists, etc. They can make scripts and Python files to do stuff at will rather than waiting for a tools engineer. Yeah, like I think that's probably kind of like the sweet spot for like LLM generated code, just like little kind of utility scripts, which, you know, just do, you know, like do little batch jobs and that. But like architecting a big project, that's where madness lies. That's the road to Gastown. Oh, Just as which unfortunately is my entire job in engine tooling and pipeline development. Yeah, I think though that you're still kind of in a stronger position, because at some point, because at the end of the day, it does require like knowledge of the internal system that you're attaching to, and presumably a large amount of that is like proprietary knowledge that would not be reflected with all the crap the model was trained on. So, you know, there still needs to be a guiding hand here and there. Yeah, Just in Time says, it still struggles during the hard stuff like functional automated testing and perf capture and analysis, which I've gotten to lean on more over time. Yeah. Earlier in my career, I was skeptical of tests. Now, having worked on a few code bases which have loads and loads of regressions that have happened as easy as breathing, I was actually tests are great. I love automated testing. Maybe I'm not quite as insane as to like write all the tests before I write the code, but I do like regression testing. Regression testing is nice. Oh, where were we? Okay, so we get this icon out of the thing. We detach the resource. What is SF? SF is okay, let's look at the Motorola instruction manual. SCC. Co-processor condition. SF. No. SF. Tell me all about SF. P-test. SF space. Signaling false. What the hell's signaling false? Okay, signaling not a number. Oh, it's a... Exception status byte. The exception status byte contains a bit for every floating point exception. Oh. Okay. Error signaling? Is that what it's used for? Like, hang on. Is this like a Macintosh thing? Because I noticed that it happened after detach resource. Is it doing some kind of spacely sprocket signaling? Compare signaling if valid, if unordered. Okay, given a handle to resource. Release resource. Is it release resource? No, detach resource. Okay. Replace the handle to the resource in the resource output. Nil. Will do nothing and res error function return code res not found. I don't know. Maybe I'll put it in as a comment. I'm pretty sure it just overwrites whatever's in DO. Okay, so 1 GZ basic stir 140. Okay, then another ZBasic function, which I haven't done yet. ZBasic unc 160 must be file related because argument 1 is the file ID. Oh, cool! And then it's got some offset here, which I don't know what it is. Okay, and then it passes a callback. Oh no, it's a variable. It's a variable. Okay, this var I16 1036. Okay, so what functions can you do that take a file ID? It's going to be here in our ZBasic reference, I guess. Okay, read file, E126. Oh, page 104. Okay, files. Creating and opening files. Okay, so we've got open R. Deleting files. Renaming files. Printing a file. Oh, it could be writing? Oh no, it's read only. So it has to be something that can be done with a read handle. Do I have... Yeah, okay, I've got... I've got read hash in my instruction ref. Okay, we'll type this up as we go. Okay, and then there's another GZ basic Unc 9, which is 1. So much for being able to infer what each of these things are. Okay. The hell? Okay. Alright, what we're going to do now is we're going to open up our friend Gidra and see if we can figure out what some of these unknown unknowns are. Assuming that this opens up. Yep, okay. Oh, it's got crash data. Sure. I'd love to recover changes. Okay. So here's the disassembled ZBasic internal program code. And that should line up with these tags here. So if we look up unknown 160, to AB4. To ABC, to AB4. Okay, so it's just a thunk for something else. Right, and it changes. So some of these ZBasic functions are a little squirrely, and they just change some state inside the engine, and then something else actually does the work. Compared to like 2AAC, which... Huh, okay. Is this... Yeah, this is the ZBasic 300. So what's going on there? Because like, here... Oh, I see. Okay, right. Yeah, so the function after that calls read. Oh, it's because okay, so this... Oh, because it's just a subroutine. Okay. BSR is branch subroutine, which means that it returns back here. BRA is just like a perma jump, which then means it goes back the normal way. Okay, so we just got to disassemble this, and then we'll get the key information that we need. So, which one was it? 2AB4. So whatever this function does, Okay, so this function also calls read. Calls this thing, which I'm guessing sets up like a parameter block. What was the calling convention on this? Yeah, okay, so we pass in... We pass in a 32-bit pointer as AO, so let's just sort out this function. Let's go edit function, custom storage, and then we're gonna say param1 is uint32t. Oh, actually, oh, correct. So unsigned long, and then we go register. Crap. Okay. Storage A0. Okay, so it's a pointer to something. Or at least it's treated as a pointer to something. Unless, of course, there is code in here. Yeah, okay, there's code in here which takes AO and does something with it. Is this... So there's ivar1. What's... Okay. Does this return A0? I can't remember. Like, Gidra not so good for having like multiple return values. It struggles for like these little assembler functions which can return stuff across multiple registers. So that might actually be a bit of a pain for us. Because like this definitely consumes... Well, create something in A1 and then, yeah, it consumes A0 and D0. So let's at least just edit the function for that. Custom storage. I'll just say ulong. A0. D0. Okay, and then... Right, and okay, so technically what it returns is this the something something register. Because that's all of this. That's what all of this modifies. So if we edit the function signature. Oh no, it actually returns AO as well. Because the final thing that it does is... Actually no, it doesn't. So it moves parameter 1 into here. Then it okay, so if we were to go like edit function signature and then change it to ulong. Yeah, okay. That seems legit. Then we go back to here. Function signature, so that we've got okay, and then it returns a param block. How does it know that's a param? I guess. Oh, okay, because this returns. Okay, so edit the function signature again, and what it actually returns is a pointer to a. Huh? Oh wait, no, because read is. Yeah, it's just a pointer. Okay, so if we change this to be as a file param block rec. Yeah. Yeah, okay. And now, because we've associated with the right struct type, we've got all of these little guys. All these little guys now line up. So okay, interesting. It would appear that oh, okay. No, it's not quite lining up because you can see it's wrapped around. What type of okay, PB read. Okay, so this is what I've got written down for this. So if we compare, we've got IO, yeah, IO completion, IO result, IO. Yeah, okay, it's wrong. Or rather, like, I've got. Oh no, sorry, the offset's slightly off. That's correct. So IO vref number is 16, which should be. Or hex 16, which would be 22. Vref num, fref num. Ah, but okay, this is all slightly different then. So yeah, okay, I've still got it a bit wrong. IO parameter block data. Okay, so it is slightly different. So we'll go back into here. Is this okay? How do we make a copy of this? Clear, duplicate, select component. I just want to make a copy of this. So we copy and then paste and then edit this. Yeah, alright. And then Because there's like 4 different parameter block types that have a union with each other, and we need to know exactly which type it is for all the stuff to make sense. So let's get that sorted. Okay, so everything is correct up until vref num, and then after that we got to start changing. So get out of here. So say you short. Go. Come on. IO ref num. Ucar. I have to double check that these ones, they might line up on the 2-byte boundary, which would then wreck all of the addressing. Okay, just pointer IMISC pointer rec buffer ulong rec count you short pause mode ulong pause offset. Okay then, and if we were to just double check to confirm that they're at the right spot. Okay, so we have IRF numbers here at 24. This is at 32, which is good. 36, 40, 40, 46. Okay, good. Great. Now we can go back into here, edit data type. No. Change data type. Sorry, retype return. Okay, and then we go back. Oops. Edit function. Dang it. Alright, I've gotten lost. Where's 160? 2AB4. Okay, so does this look more correct? Yes, it does. Okay, so now it's setting the correct bits and bobs in the structure, which means we can give this a name. We can say this is going to be the buffer. We can say this is going to be the rec count. And that given that, given that this is going to be returning just I mean, this is okay. This is returning PI var 1. I mean, that seems right, because then read takes in a parameter block. So okay, so rec count is the requested number of bytes and act count is the actual number of bytes. So we're okay, so it's just asking, so it's asking for just like a number of bytes and then it either gets it or it doesn't. Makes sense. Makes sense. So I guess this is just like another type of read. Alright, well, that answers a lot of the questions that I had. It does not answer what that weird, like, what the hell, what's this? Why is this here? Where did this come from? I guess it could be doing line input or something like that. Okay, read is the counterpart of write. It is used to read back data created with write in condensed high-speed format. This is the most efficient way of reading files. Reads 10 characters into A dollars, an integer number into Z dollars, and 2 oh no. Oh no, okay. I think I understand. I hate it. It just occurs to me that, yeah, like, you can do the equivalent of, like, scanf with this function, which would then be like a variadic multi-typed multi-typed approach to using read. I'm not sure if there's just like various different types that get passed to this. Also, okay, the other thing is that fine, alright, so we overwrite whatever this is. I'm guessing some kind of you know what, I have no idea what this is. But then we call zbasic160 with just A0. I mean, it could also be like file ID number 1. I don't get it though. Okay, so because we've got this function here. It takes in the target buffer is an A0, and then the number of bytes that it wants is in this other thing. So does it want 1 byte? Is it loading it into? Is it loading it into a pointer that is specified by this, or does it just load it into this variable? I don't understand. Okay, the only place in the code var 1036. Is this the only place in the code that this is used? It sure is. It sure is. Great. Maybe we should find out what Unk9 is. Maybe we'll have more luck there. Okay, 1742. Yep, okay, there's a function. Which calls this, but that's a branch. Okay, and then immediately after that we have oh, it's like a jump table? Oh, okay, and we've got a syscall that needs to be converted. Windows, script manager. Analysis, M68K. Okay. Okay, well there is a trap. Oh, read. PB read is the trap. Okay, so it calls. Yeah, as expected, it calls the read API. Does a bunch of crap. I don't understand why the disassembler says the subroutine does not return. It absolutely does return. There's a return statement here. Why would you claim that it doesn't return? Okay, well it calls this method, which grabs some stuff, runs it through read, then okay, then there's some event handlers. Yeah, the Z basic control flow is a little nutty. Okay, let's just press on. Okay, this is probably going to be another loop. Yeah, okay, it's another loop. Well, it's a nested loop, in fact. Okay, and then that's right. That Okay, okay. What the hell? Okay. 64? Yeah, it's 64. And then this. Okay, and then that. Oh, wait, no, I got it around the wrong way. Okay, and then. Okay. More loops for I equals 0. I. A for E. Okay, no, it is a double loop. Okay, greater than or equal to 50 I plus plus 129 08 08 8A. Less than or equal to 3. This var. Okay, so that's the. Okay, so fetch something from the pattern buffer. Wait, what? So we got. So 4 times I. Okay, expected 0, have 1. But that can't, I mean. Oh, okay, that returns a number. Oh, right, okay, and then we're gonna have to... Okay, so this is loading up the pattern buffer, however... This doesn't... Yeah, okay, this is gonna be a problem. Okay, so this is now entering the part of the code which is... Actually, this is... Okay, that explains it. So... This bit of the code is fetching data from the puzzle file. And initially I wasn't kind of clear as to how it worked. Like, it seemed like this is just a raw pointer to some data, and then... Or sorry, it seemed like this is a raw pointer to the data in the file, and then we're just kind of incrementing it as we go. And then outputting it in chunks like this, which is fine. I guess that means that, like, I32696 must be like a data pointer containing all of the... Yeah. So this must be returning a pointer to all the stuff in the file. So maybe maybe this is the equivalent of like $10. Well, I mean, the issue with that though is that this is for like a piece of memory that already exists, whereas it looks like the calling convention for this is to return a pointer. Because yeah, it's referred to in here when we're like fetching stuff, but this looks like it's meant to return a pointer to the raw data in here, which makes me wonder, is there a different way of doing this? Okay, rename, print, write, route, input, line input. Getting important information about a specific file. Oh, okay. This is for like moving the file pointer around. Record 23, like, the hell's record? Record is optional. If the record statement is not used in a program, the pointer will have a starting position of record 0, location 0. Okay. Oh, is this maybe like getting this? Okay. How about maybe this command could be about like fetching the entire contents of the, like, get file length. Is that possible? Where's the equivalent of like tell? Okay, returns the current record number, returns the current location with the current record, returns the last, like, LOF. If there are 1 or 0 records in the file, LOF will return 1. Because, yeah, these are the only places that 1036 is referred to. Alright. Well, very quickly we'll do one last test and then we might wrap up. So, Mac. So I'm just gonna open up my ZBasic machine. So 10 lock. Was it lock? Okay, we'll do rec lock and lock. Print lock 120. Print rec 130. Print lock 1. Compile. Okay, so we've created a compiled ZBasic program. We can go into here. Yeah, Mac binary. So hcopy Mac binary. Oh my word, what was it? It was rec. Oh no, it was lock. Okay, so we can see here that ZBasic 154, ZBasic 155, and ZBasic 156 correspond to these three: lock, ref, and lock. So this is how I've been figuring out what each of these indexes map to. It was 154, 155, and 156, right? Okay. Okay. And they all take DO. was none of the ones that I wanted though, but we've... Yeah. I suppose we may as well like figure out how this multi-read thing works. Even though it'll probably make me very sad. So we go 10 dim. Oh crap, I can't even remember how. Nope. 10 dim $8. 10. Is that right? Okay, good. And then we go dim $8, 10 Z percentage K dollars to. It's gonna be okay. No, that works. 20 read number 1 $8 10 Z percentage K dollars 2. Okay, and that compiled. Okay. Okay, no, it just calls it. Okay, I think we're getting closer. So yeah, there's a different read function for each type. So really, what I had marked as read thing is read stir. And then 159 is going to be read. Okay, is the integer type like when they say integer? I can't remember if like the percentage means that it's a short integer or not. Okay. Okay, integer I think is 2 bytes, and then okay, ampersand is 4 bytes. I understand. I understand. So it's actually 159 read short. Ooh, could that mean that like 160 is reading along? So if we go like 40, where should we go? 11 dim x at, and then 40 read 1 x at. Is that legit? Compile. Yep, good. There we go. Okay, good. Oh, and we've got to know... Apparently that's enough to mess with this piece of state. I don't know why it would do that in line. That seems like kind of a weird thing to do, but they do it. They sure do. Okay, so let's... 160, which is read long. Okay, so that clears up some of the mystery. And how does it end up reading that? Yeah, okay, you pass in the variable ID that you want to read it into, and it figures it out. Okay. Makes sense. Ah, okay, so this must be like reading the little table at the top of the little table at the top of the puzzle file to get all of the cool stuff. So like if I go into full 2 and we dump Fool's puzzles, like there's some detritus at the top because there's like the Mac binary header and everything. But if we get to, I think, the start here, yeah, we've got definitely like a table full of addresses in that.
Hello, please press a code number.
Oh, thank you very much for the follow, L1 Fed. Good to have you around. Kinokos asks which best describes the work that you do and includes a link to something on Discord, which I'm gonna just okay. Difficulty level, easiest, easy. Hang on, let me see if I can just copy the link to my other browser. Easiest, easy, moderate, a little stress, more stress, very stressing, annoying, really annoying, very frustrating, or letter of complaint. I'm gonna call like the stuff that I'm working on now. This is number 2. It's easy. It's just little bit of kind of translating from one thing to the other, occasionally getting to, you know, pop up, you know, have a look under the covers. Like, I don't know, compared to Director is about between a 6 and a 7 depending on the day, because it's very difficult to refactor and there's like all of these, you got to be wary about making changes in a way that won't break all of the other stuff, and you've got to keep all of that in mind, and then that kind of takes away from the enjoyment just a little any old way. I think that we're almost done. We're almost done for the evening. We got pretty far actually. I wonder what Unk 9 is then, because it's not read into a string variable, because we have that tracked. Is there like a special read mode? Okay, so we've got like open, rename, print, write, route. Oh, is this the length of the file maybe? How long is this? 5 dBE. Okay, so 5 dBF, I think. Oh wait, but this could also be just more of the header. This isn't necessarily. Hang on. Let's easy way of doing this. So we go Mac unpack. If we were to do 3-fork mode for Fool's Puzzles. Yeah. So now if we were to just dump the data. Yeah, okay, there's like a whole bunch of resource fork stuff that was throwing me off. So if we look at like the very first bit of the data, we get... Oh, okay, we get this number. Fair enough. I was kind of expecting there to be like a number that would indicate like how big this table is, but perhaps that isn't there. Anyway, I think it is about time to close shop for tonight. Yeah, thanks everyone for popping in. This is super fun as always. I will probably be back on Thursday doing Macromedia Director stuff. But until then, who's streaming? Okay, Point Then Click is playing Cream of Fandango, so we're gonna go say hi. But yeah, have a wonderful rest of your evening, /day, /morning. I don't know what time zone you're in, but it doesn't matter because I'm sure I'll be alright. See you next time.